Welcome to the first lesson of 3 for fractions. Today we will look at the very basics of fractions to make sure you have a secure understanding of the basics to move on to the more difficult operations where we will be looking at timesing, dividing, adding and subtracting. I hope you managed to download the worksheets and have a go at these starter questions. We'll start by going through these. If we look at the top left box first, this question is asking you to solve. Whenever you see a solve question, you instantly should be thinking, I need to get the unknown on its own. The unknown here is v. There are many different ways to lay out solving equations. I do it like this. If you've done it slightly different and got the same answer, that's absolutely fine. The first step that we need to do when looking at solving this equation is to get rid of this 2 here. The goal is to get this on its own. We need to get rid of this and get rid of this, so it says v equals. To do this, we will always leave whatever is attached to the unknown till last, so this 8 is attached, so we'll leave it until last. Therefore, we should get rid of this plus 2. When solving equations, remember, you always need to do the opposite. The opposite of plus 2 is minus 2, so we will minus 2 from both sides. Remember, you have to do it to both sides to keep it equal. If I minus this 2, I've got rid of it, so I'm left with 8v, and if I minus 2 from the right side, 34 take away 2 is 32. I finally then need to get rid of this 8. Remember, 8v means 8 times v, and we do the opposite, so the opposite of timesing by 8 would be dividing by 8. So I divide both sides by 8, which will eliminate this 8, because 8 divided by 8 is 1, which is perfect because we want v on its own. And remember, a lot of students forget to do this side. 32 divided by 8 is 4, so the answer to that one is 4. Moving over to the top right box. Simplify. When you see the word simplify with some algebra expressions, you have to remember that like terms go together. So if I'm looking at 7p minus 8p, a tip, this minus is not just floating in between these two things, it is attached to this 9p, so that is minus 9p, and the same applies, this is minus 7q. I need to look for like terms. Well, I can see this p and this p are like terms, and this q is a different term because it's a different letter. So if I simplify this, I can do this expression here, 7p take away 9p. Well, if I'm at 7 and I take away 9, it's going to get me down to minus 2. Okay, so this answer will be minus 2p, and then this could not be collected with anything else because it's on its own, so it's just the minus 7q. And that is it. You don't need to solve this. A lot of students try to start solving it and adding stuff on each side. There is no equal sign. This is just an expression. There's no equal sign and there's no need to solve. You just have to collect the things that are the same together, the terms that are the same. Moving on to the bottom left. Here you were given a sequence, and I asked you to write the next 2 terms in the sequence. So the key to doing sequence questions is you have to realise, what is this sequence going up in? Is it a linear sequence? Is it going up in the same amount? This one is, and we can see here clearly it's going up by 2. So you probably found this one nice and easy. If I add 2 to 40 to get the next term, I would get 42. And if I add 2 to 42, I would have got 44. The next extension question was asking you to find the nth term. Now, if you're unsure about what the nth term is, I wouldn't worry too much about it. It will be a lesson that I'll be going through in the future, but the nth term, for those of you that may have given it a go, would be 2n. And then how do we get from 2 all the way up to 34? You add 32, so it's going to be 2n plus 32. Okay, but as long as you got those 2 terms there, that was the main part of this question. moving over to the bottom right, being able to multiply using the column is very, very important. Remember, the method is to do this one times this one, and then this one times this one. Then you move across to the 3, and you do that times that, and that times that. So if we do that, 0 times 2 is 0, and 9 times 0 is 0, so we end up with just 0 and 0 for that first column. Now when we move across to this 3 to times this by 2 and this by 9, remember we have to put in a placeholder 0. When we've moved across, we need to start in line with this, so we need to put in a 0 before we start. Now we can do it. 3 times 2 is 6. 3 times 9 is 27. Sometimes you carry the 2, but we don't have to here because there's no other digits that we need to times by 3. So we can just put our 27 in there. And then we add. Okay, we add these together. Well, clearly that's just going to be the same. So the answer is 2760. That would have been your final answer. Okay, so there are your start questions. Moving into fractions, like I said, we're going to start from the very basics of fractions to make sure you have your fundamentals. If you already know this and you've looked through the sheets and you think to yourself, I can do this, you might just want to tune in for the fractions 2 and 3 lessons where we'll be looking at doing all of the operations with mixed numbers and improper fractions. But today we'll be looking at what mixed numbers are, what improper fractions are, how do we switch between them, and also simplifying. So if we just start by looking at the basics, I'm sure you already know this. The top part of a fraction is called the numerator, and the bottom part of a fraction is called the denominator. A mixed number looks like this. So what I just want us to do here is just let's fill in some numbers here. We could put in, what would be a fraction we could fill in? We could put just a half. That's a fraction that everybody knows. A mixed number, we could have 3 and 1/4. Okay, so 3 and 1/4. What does that mean? Well, that means that we have got, and this is a note that you should definitely add, we've got 3 whole ones, and then we have a quarter. So a mixed number just means that we have a mix of whole numbers and fractions. That's why it's called a mixed number, because we have a whole number here. We've got 3 whole ones, and in this example we've got 1/4. So we've got 3 whole ones and 1/4. We'll be looking at how do we change between this and this next part, which says improper fraction. So most of the students that I teach call this top heavy, because this sort of explains more about what it is than improper fraction. But a top heavy fraction just means that the numerator on the top is bigger than the denominator on the bottom. So you could make up any example you want there. An example that we could just go with, let's just say 5/2. This is an improper top heavy fraction because the numerator is bigger than the denominator. So that is the very, very basics. The thing that most students struggle with when doing fractions is their tables. If you don't know your times tables very well, you instantly find fractions a lot harder than it is, because a lot of simplifying and changing between top heavy and impropers and making common denominators and everything that you need to do to be good at fractions requires you to have a very good understanding of your tables off the top of your head. So what I've got here for you is a times table grid. So if you're not very confident with it, you can have that to the side and you can use it to help you. So we're going to look now at simplifying fractions. And this is where your times tables will really come in useful. Simplifying fractions means, can we break a fraction down to the smallest numbers possible? So the goal to this question is, what's the biggest factor? And remember, a factor just means a number. It's a fancy way to say a number that goes into both. The biggest factor, the biggest number that goes into both the numerator and the denominator. So if we're looking at my numerator and my denominator in this example, I'm thinking to myself, what is the biggest number that I know that can go into 15 and 20? Well, clearly 5. 5 goes into 15 and 5 goes into 20. So how we simplify this is we ask ourselves, how many 5s go into 15? And this is why you need to know your tables. 3. 3 5s go into 15. How many 5s go into 20? 4. So 15 over 20 is exactly the same as 3 over 4. So we can look at an example on a calculator where we can prove that. We can say to ourselves, if I put in 15 over 20 and press equals, the decimal I get, if you see, is 0.75. Okay, the decimal that it's given me is 0.75. Now, a lot of you should already know that we simplified that to 3/4. So if I put 3/4 in, and a lot of you probably do know that 3/4 is also 0.75. So even though those fractions look completely different, they are in fact exactly the same. They're what we call equivalent. So when you simplify a fraction, you are just making the numbers of the numerator and denominator as small as possible, given the same factors of top and bottom, and essentially it is the same number. And then you can always look at your answer and be like, can I simplify that anymore? Can that go down any further? No. Nothing goes into 3 and 4, apart from 1, which would be pointless. So that is as simple as it will go. And definitely because 3, remember, is a prime number, which means the only factors of 3 are 3 and 1. So very, very similar. I'd like you to try and have a go at that one. You got 15 over 18. Using the same method, think to yourself, what is the biggest number that goes into 15 and 18? And give it a go. So what number goes into 15 and what number goes into 18? The biggest is always the best because it's less work in the long run. And we'll look at an example where maybe you don't find the biggest number and you can still get to the right answer. So 15 over 18. Hopefully you realised 3. 3 is the biggest number that goes into 15 and 18. And you ask yourselves, how many times does 3 go into 15? 5. How many times does 3 go into 18? 6. So the answer to this question would be 5 over 6. And again, ask yourself, can I get it any smaller? No. Nothing goes into 5 and 6 apart from 1, which if you put 1 in, you're going to get the same answer over and over again. So I have some questions here for you to practice. I just want to look at the first one, and I want to explain to you that you don't always need to find the biggest. If you're not massively confident on your tables, you can actually do it in multiple steps. So if I'm looking at this first one, we've got 6 over 12. You need to think to yourself, what number do I know that goes into 6 and 12? Well, there's quite a few that go into 6 and 12. Let's just say, good little trick, they're both even. 6 is even, 12 is even. 2 goes into both. How many times does 2 go into 6? 3. How many times does 2 go into 12? 6. This answer is not as simple as it can be. It is simplified, but it's not what we call simplified fully. If a question ever says simplify fully, it wants it to be as small as possible. So I'm looking at 3 and 6 thinking, what goes into both of those? Well, 3. 3 goes into 3 and 6. How many times does 3 go into 3? Once. How many times does 3 go into 6? Twice. And you might have spotted instantly that 6 over 12 is a half, which is brilliant because that means 6 is the biggest number that goes into 6. 6 goes into 6 once. 6 goes into 12 twice. So I would like you to just work through those questions. I'll give you sort of 30, 40 seconds just to get a head start on me, and then I'll start to sort of put the answers up. If you have any questions or you're unsure about any of the examples there, just put a comment in. So really, really useful tip is to always check, does the smallest number in my fraction, so in this case, if I'm looking at this one, the numerator, 3, go into the denominator? If it does, that's the quickest way to get the answer. So number 18 over 24. There's multiple ways you can do this. You could half it and get 9 over 12. And then realise what goes into 9 and 12, 3. 3 goes into 9 3 times. 3 goes into 12 4 times. Or you could have spotted 6 goes in, and that would have given you the answer without the middle step I just did. So, 9 and 24. Again, this is why knowing your tables is really, really useful. So, I'm just going to go through these now and put in the answers for you. 3 over 8, and here we've got 3 over 8. This one, you should have spotted, that is top heavy. That is an improper fraction. So, what goes into both? Well, there's multiple ways you can do this. You could half it. You could say, 3. If I half the bottom and half the top, 8. So that is 8 over 3. And as you can see, that is what we call the reciprocal. They are the same, they are just flipped. So you might just want to add that note there. It's reciprocal, which means a mathematical way to say flip. 16 over 16, that's just 1. That goes down to 1. 32 divided by 16 over 16, that actually is just 2 whole ones. And then you should have got a half for this one, because 16 goes into 16 once and 16 goes into 32 twice, or you could have gone and halved it until you got down to a half. Now the bottom one, if you tried the bottom one, you can't simplify it. 31 is a prime number. Okay, so that means the only factors that go into 31 are 31 and 1. And 31 does definitely not go into 15. Therefore, we cannot simplify that. So that is almost like a trick question. Can we simplify this? No. This is already in its simplest form. Okay. So moving on, now we're going to look at how do we change improper fractions to mixed numbers. So we discussed earlier that a mixed number looks like this. You've got a whole number there and then a fraction. So it's a mix of a whole number and a fraction. So we need to turn all of these improper fractions on the page into mixed numbers. So if we look at the worked example, we have got the fraction 6/5. Clearly that is improper, top heavy, because the top number 6 is bigger than the bottom number 5. How do we do it? Well, we need to know how many, remember it's a whole number and a fraction. So we need to know how many whole times does 5 go into 6? Well, 5, 10, 15. Clearly, 5 only goes into 6 one whole time. So this is one whole one with a fraction left over. The fraction, the tip here, the bottom will always be the same as whatever fraction, improper fraction you're looking at. So if I'm looking at 6/5, I know the denominator, the bottom will always be 5. So one whole one, and I need to know how many are left over. So 5 goes into 6 once, and how do I get from 5 to 6? Well, there's 1 left over. Okay, so there's 1 left over. So my answer is one whole one and 1/5 left over. So have a go at the next one under your term. You need to convert 13/5 into a mixed number. So I need a whole number and my leftover fraction. Here's your tip. 5 will be the bottom. It will always remain the same. So ask yourself, how many times does 5 go into 13 whole, and how many have you got left over? So 5 goes into 13 whole 2 times, because 5, 10, 15. 15 is bigger than 13. So it's 2 whole ones, and how do I get from 10 to 13? There's 3 left over. So it's 2 whole ones and 3 left over. So knowing your tables, very, very useful. It's all about how many times does the denominator, the bottom number, go into the numerator, the top number, whole, and then you work out how many are left over. Good tip here is you know the denominator will always be the same. So this would be 5 because that's 5, this would be 5 because that's 5. So if I come down and you start to look at these practice questions, and you can use your tables if you're unsure, but ask yourself, how many times does 4 go into 7 whole? 4. So I need a whole one and then a fraction. Remember the tip, 4 will be the same on the bottom of the fraction. So you just need to work out what goes here and what goes here. How many times does 4 go into 7? 4, 8, 12. Well, 8 and 12 are too big, so it's one whole one. And how many left over? How do you get from 4 to 7? It's one whole one and 3 left over, because 1 times 4 is 4. How do I get to 7? There's 3. So work through those, and I'll just do them without talking. So if you have got to this one, 18 and 8, how many times does 8 go into 18? Twice, because 2 times 8 is 16, with 2 left over because 16 to 18 is 2 remainder. We can see, based upon our last set of questions, what could we do to this fraction? Because you always should be thinking, whenever doing fractions, you should always be thinking, can I simplify? Can I simplify? So here, 2 over 8, can we simplify that? Does 2 go into 8? Yeah. So we could simplify this to 2 whole ones, stay the same. How many times does 2 go into 2? Once. How many times does 2 go into 8? 4. So that could be simplified to a quarter. Okay, so you always want to be looking if you can simplify. How many times does 8 go into 36? Well, 4 8s are 32. How many have you got left over to get from 32 to 36? It's going to be 4 8s. And you spot there that, can that be simplified? Yes, that's a half. So that's 4 and a half. How many times does 4 go into 36 whole? It's actually 9, with nothing left over. So there is no fraction, because there's no remainder to get us to 36, because 4 goes into 36 9 whole times. (36 over 2), that is just 18. How many times does 2 go into 37 whole? Well, we know 18 is 36, so 18 whole ones with 1 half left over. How many times does 3 go into 37? Again, knowing your tables is 12, would be 36 with 1/3 left over. Now these here with these x's can get quite confusing, but it's the same. How many times does 3 go into 37? Well, we've just done it. It's 12 and 1/3 x. We've got an x as well. It's exactly the same, there's just an x involved. How many times does 3 go into 74? Well, you don't know your times tables up to 74 in the 3. So it will be 24 and 2/3. So if you do need to work that out, you could do a bus stop and see how many whole ones go in. Okay, moving on to the opposite way. So we're just going to finish here, and then I've got some practice questions for you to try on your own. We're just going to finish here. The reason, and if you already knew this, that's absolutely fine. If it's more so you're confused with how to add, subtract, mix numbers and divide and multiply, that will be coming up in fractions 2 and 3. But it's just making sure if you didn't have the fundamentals for this, you have them before we move on to that. So we're going the opposite way now. So we need to work backwards. They've given us a mixed number, 1 and 1/3, and we need to convert that into an improper top-heavy fraction. So I'm just going to go off on a bit of a tangent and talk about 1 and 1/3. What does that mean? Well, it means we've got 1 whole one. And what you really need to understand here, because there's a little method I'm going to teach you of how to turn this straight away into a top-heavy fraction, but just for your understanding, you should know that 1 whole one, well, what is a whole when we're talking about a third, 3 as our denominator. A whole would be 3 over 3. So we've got 3 over 3, right? That is a whole, because what is 3 divided by 3? 1. So we've got 3 over 3, and then another third. that's what this is saying. You've got a whole one, which in this context would be 3 over 3. So I'll do a different one here. Let's just say we've got 1 and 2/5. Well, what is a whole when we're talking about fifths? Well, clearly it would be 5 over 5. Right? And then we've got a 2/5. So what happens when we add the one on the left? We're allowed to add these because the denominator is the same, which we'll get to in further lessons. But that's going to be 4 over 3, which is top heavy. So to turn this mixed, this is the long method that I wouldn't expect you to do, but it's the reasoning behind it. This here would be 7 over 5, because we've got one whole one, which is 5 over 5, and then 2/5 left over, so 5 over 5 and 2/5 would be 7 over 5, and again, that's top heavy. But the method, you don't want to be doing this every time. It's not very effective. Mathematicians, very lazy. The quicker we can do something, the better. So the method to do this is essentially, we've got 3 times the 1, and that's how we're getting this. And here we've got 5 times the 1, and that's how we're getting this. So if we go back to your worksheet, the method to convert a mixed number into an improper fraction is, you take the denominator and you times it by the numerator, the whole number, sorry. Then you add the numerator. So what do I mean? You do 3 times 1, which is 3, add 1, which is 4. So this is 4 over, same tip as last time, the denominator is going to be the same. So it's 4/3, because 3 times 1 is 3, plus 1 is 4. 4/3. Exactly the same for the next one. You're going to take the denominator. So you can you can just fill in. You know the denominator is going to be 3, because it's going to be the same. All you need to work out is what's the top. Well, remember, it's the bottom number times by the whole number, the denominator times by the whole number, plus the numerator. So if we think about that, 3 times 2 is 6, plus 1 is 7. Okay? And that's it. All you do, the denominator stays the same, and you take the denominator, times it by the whole number, and add the numerator. That's the quick method to get a mixed number into a top heavy. So there's some questions for you to practice. My advice for you would be just fill in. You know what these denominators are going to be. All of these ones are just going to be 5, because the 5 is on the bottom. You just need to work out what goes on top. And remember, you do this times the whole number plus the top number. So you do 5 times 1 is 5, plus 1 is 6. And these questions, you can do them very, very quickly. Once you know the method, they're very easy. So I will just complete them. You can do them as well. I won't talk, I'll just get them done. And you can check, see if you've got it right. So hopefully you managed to get those ones. Again, it's just a case of the denominator stays the same, and you just take the denominator, times it by the whole number and add the top. So this one here, for example, 9 times 3 is 27, plus 3 is 30, over the original 9. Just want to focus on these last two here. And go through them. We've got 9 times 4. 9 times 4 is 36, plus the numerator. Well, the numerator is not a number, so we've got 36 plus x. So we write it like that because you cannot just combine an x and a number together unless they're both x's. So we write it like that, and it's going to be over the original numerator, which is 9. So it's just reinforcing that method. You do this times this, which is 36, plus the top, which is just an x, so you have to write it like that. And then finally, same method. What is 4x times 4 is 4x plus 9. Well, you cannot add 4x and 9 together, so you just have to write 4x, add 9, over the original denominator, which would be x. Okay, so that will conclude this very brief introduction to mixed numbers, improper fractions, and simplifying. You need to be extremely confident at doing that to be able to confidently master adding, subtracting, dividing, and multiplying fractions, because 9 times out of 10 you'll be asked to convert these mixed numbers into top heavies, vice versa, and simplify. Simplifying is the key to a lot of questions to get full marks, and it will always make your life easier. So knowing your tables, being secure on those methods I've just gone through, will make fractions 2 and fractions 3 much easier. So there are some questions for you to practice here. I've linked the answers in the description, so you can have a go at those either now or in your own time. And if you check the description, there will be some answers for you there. Okay, so hopefully see you in the next fractions lesson. We will be looking more at multiplying, dividing, and then adding and subtracting. Thank you.